Hello everyone. In this video we're going to continue our discussion about the hypothesis tests, and specifically we're going to talk about one-sided hypothesis test here on the population mean, which is the mu, and then we'll talk about what p-value is, type 2 error probabilities, which we showed with beta, and a power of any hypothesis test, and also how to choose an appropriate sample size, because hypothesis test is all about sampling. You don't have access to the entire population, so what you do is you take a sample and you do the hypothesis test on the sample. But what is the appropriate sample size is what we're going to talk about here as well. Let's start with some refresher of what we talked about so far. Here it says let x1 through xn be a random sample of a population that are IID. IID stands for independent and identically distributed. If the population is not normally distributed, but the sample size is greater than 30, and 30 is a rule of thumb, is a rough estimate, then the sampling distribution of the mean that we talked about is approximately normal. That is the whole point of central limit theorem, as a result of central limit theorem. So in this part says identify the critical region in figure below for a two-sided alternative hypothesis on the mean. And standard deviation is known. A two-sided alternative hypothesis means when you have alternative hypothesis where it has mu, and that means the hypothesis is on the mean, is not equal to a number. And we just call that number in the generic form mu naught. The fact that makes it a two-sided alternative hypothesis is the inequality sign here. So we already talked about this type of hypothesis testing before, and we know that the critical region are these two areas, where if our test statistic ends up above the z of alpha over 2 or below negative z of alpha over 2, we would reject the null hypothesis. So critical region really depends on these two values, and those two values depends on alpha, right? The area under the curve is alpha over 2. The summation of those two areas is alpha, which is probability of type 1 error. We have to be able to read these values so we know where the critical region starts. Here it's asking us for what is the z of alpha over 2 if alpha is 0.1. And we already talked about how to find these critical values from the z table or normal distribution table. And in this case, z of alpha over 2 will be z of 0.05, which is 1.64. And you can double check that on the normal distribution table. In fact, there are some common z values that I'm just going to mention here, and you can have them in mind so later you won't go to the normal distribution table every time. You know, we might have a z of 0.025, that is 1.96, and then a z of 0.005, that is 2.57, and the other common z value is z of 0.01, which is 2.32. So these are common z values that we typically use in problems. The second bullet says rejecting the null hypothesis when it is true is defined as a what type of error? If the null hypothesis is true and then we end up rejecting it, is an error, and that is called the type 1 error. And the other way around is type 2 errors. Failing to reject the null hypothesis when it is false is defined as type 2 error. We already talked about type 1 error in details last time. We're going to talk about type 2 error today. So with that, which was a quick refresher of what we talked about so far, let's jump into a new type of hypothesis testing, and that is the one-sided hypothesis test. Here it says, what if the alternative hypothesis, H1, is mu more than mu naught? Mu naught is a number. Depending on your test, it can be any value. It can have any value. So in this case, because the alternative hypothesis has this greater than sign, our test would look like this, where we have only one critical region, and that is to the right of the distribution, and this area is alpha under the curve. That means this point is z of alpha. So for example, if alpha of the test is 0.05, this value here is 0 of 0.05, which is 1.64. So this, because of this sign in our alternative hypothesis, we call this type of test one-sided hypothesis test. And we reject the null hypothesis if our test statistic, which is the same test statistic that we had before. Just to remind you, that is x bar, your sample average, minus mu naught, this number here, over sigma square root of n, and n is your sample size. If your test stat ends up being greater than z of alpha, which is this number here, then you end up in this region, which is the critical region, and you would reject the null hypothesis. The opposite of that is when you have a one-sided hypothesis when mu is less than mu naught. And again, mu naught is a value, is a number. And in that case, you reject the null hypothesis if your test stat is less than negative z of alpha. How would that look like? You probably can guess how would that look like. In that case, you would have your critical region to the left of the normal distribution, and this value right here, which determines your critical region, is negative z of alpha. So again, if alpha is 0.05, negative z of 0.05 is negative 1.64. If your test stat ends up being less than negative 1.64, you would reject the null hypothesis. So this is more a generic description of a one-sided hypothesis test. We're going to look at some examples.